Hi guys, let's look at the next question. The next question that we are doing in similarity is question number 14. It says triangle ABC and triangle AMP are right angle triangled, and some length of some line segments are giving. We need to prove that ABC is similar to AMP. Such questions extremely simple because they already tell you which triangle to prove similar. So for my convenience, I will just draw these two triangles that we need to prove similar separately so that I can identify specific angles. So this is A, B and C. This is M, A and P. So since I have to prove ABC and AMP, let's see if I can visually find something equal already. So angle B and angle M are equal because they are 90 degree. And I notice that angle A is common in triangle AMP as well as in ABC, which means angle A is common. So we've already got our AA test. Let's just write this down. So in triangle ABC and triangle AMP, point number one, angle ABC is equal to angle AMP is equal to 90 degree. This is given. And the second part is angle BAC is equal to angle MAP. This is common angle. Perfect. So what this means is triangle ABC is similar to triangle. Let's look at the one-to-one correspondence. We got A and A equal, which means I wrote A in the first place, so A should be here. Next is B and M are equal. B was the second place, so this is M, and that leaves only P. This is by AA test. Done. So we've got this right. We need to find AB and BC. So before we do that, let's just write the dimensions that we know. We know AC is equal to 10. So AC, the big line here is 10. Next AP is 15. So the big line here is 15. Next PM is 12. Okay, so this is 12. Done. We need to figure out find AB and BC. So let's just look at this. This would give me AB upon AM is equal to AC upon AP is equal to BC upon MP. I looked at AB, the first two, so I took the first two here. Next, I looked at A and C, which is 1 and 3, so I took 1 and 3 here. And then I took 2 and 3 here, so similarly I took 2 and 3 here, M and P. Perfect. This is CSST. Done. Let's see if I know the values. AB I have to figure out, so I don't know AB. AM is given. No, AM is also not given. So if I have two variables, how would I find it? Let's look at this. AC given as 10. AP given as 15. So this is 5 into 2, 5 into 3. This is done. BC not given. MP given as 12. So BC is easy to find. I have an equation, which means let's just write this down. BC is equal to 12 into 2. 12 into 2 upon 3, which is 3,134. So this is 8 centimeter. This was simple. BC is equal to 8 centimeter. This part of the question done. But we need to find AB. Now AB is in this formula. AB upon AM is equal to 10 upon 2 upon 3. So I need to know the value of AM. So now let's look at this triangle AMP. I know AP is 15. MP is 12. Using Pythagoras theorem, I can find AM. So in triangle AMP, using Pythagoras theorem, what I get is 15 square is equal to 12 square plus AM square, which means 225 minus 144 is equal to AM square. This is 225. Why did I write 224? 225, right? 81 is equal to AM square. Therefore, AM is equal to 9 centimeter. So once I get AM is equal to 9 centimeter, I put it in this formula. AB upon 9 is equal to 2 upon 3, which means AB is equal to 2 into 9 upon 3, which is 6 centimeter. Therefore, AB is equal to 6 centimeter. So this question was fairly simple because they gave us which triangle to prove congruent, to prove similar. Once we proved similarity, we did CSST, and then we encountered a simple problem of not knowing what is AM, and Pythagoras theorem came to our rescue. Good, let's look at the next question. The next question that we do now is question number 16. So let's look at this question. Question 16 says ABCD is a rhombus, so which means AB, DC, BC and AB, all four sides are equal. So let's just write this down. Number one, AB is equal to BC is equal to CD is equal to AD. This is sides of the same rhombus. So all four sides are equal. This is one key information given right in the beginning. Let's see how can we move from here. So they want us to prove DP into CR is equal to DC into PR. So let's see if what we have to write this. Like I said, since we've been working in the fraction form, so let's write it in the fraction form and see how it works. So this is DP. Let's take PR down. So DP upon PR is equal to DC upon CR. This is basically, I've taken it in the fraction form. I took PR here and I took CR down. So let's see if I can get a triangle which I am trying to prove congruent. So I have to prove triangle DPC, which is DPC, this triangle, and PCR, this congruent. So these are two adjacent triangles. So I have already shared one trick with you, which is trick one was numerator to numerator and denominator to denominator. This will help you find which triangle to prove congruent. Trick 2, if you're looking at proving similarity, the first type of triangle that you should look at are vertically opposite triangles. Why? Because if you have a vertically opposite triangle, one angle will be equal, which is vertically opposite angle. So proving similarity becomes simpler. Next, trick 3, in case you're looking at which triangles to try and prove similar, you should look at common angles. Like the previous question that we had a common angle in it. In that case, I think it was angle A. So this is the third kind of a triangle you should look at, triangle with common angles. And trick 4 is ideally never look at adjacent triangles. Ideally, whereas if at your level in grade 9 and 10, you should be getting questions with similar triangle to prove adjacent triangles similar. So this is it is possible that you get them, but this is the most difficult one. So for now, I hope you don't get it, but even if you do, we will come back to such questions later. So don't look at adjacent triangles first. So proving this similar will be very difficult in any case, because these are in any case parallel lines, because these are this is a rhombus. So I don't have any angle which is in case of corresponding or adjacent. So in fact I would get one angle adjacent. But let's see. So let's see if I can replace DC with something, because DC is equal to DA equal to AB equal to BC. If I can replace DC with something and I can try and convert this into a simpler triangle. So let's look at, instead of DC, let's look at DA, because DC and DA are equal. So if I can get these two triangles similar, which is DPA and CPR. I'm again repeating how did I shortlist this triangle. First, using this small trick, we got DPC, and I realized the triangles that I'm getting are adjacent triangles. So that's how I moved on to another triangle which will make my life simpler in terms of vertically opposite triangles. So now I have a triangle DPA, which means all this I'm doing my calculation in my mind. So or you can even write this. So now I need to look at DA upon CR. So I am looking at two triangles which are DPA and triangle PCR. Let's see if I can get anything, if I can prove these two triangles similar. So point number 2 would be angle DPA is equal to angle RPC. Reason, vertically opposite angles are equal. Next, any other angle you can find equal? Yes, I noticed that this angle, which is angle A here and angle C here, will be equal because these are alternate angles. DA and CR are parallel and AC is the transversal. So these two angles are alternate angles. So let's just write this down. Angle DAP is equal to angle RCF. Not FP. This is not F, this is P. RCP, this is alternate angles. So that gives me point number 4. Therefore, triangle DAP is similar to triangle RCP by AA test. Now that I've got this similarity, let's just write my corresponding sides ratio, which would be DA upon RC is equal to DP upon RP is equal to AP upon CP. This is CSST. Good. Let's look at the what we need to prove, and that will help us, and that should finish this question then. So what we need to prove here is DP into CR. So we are looking at DP here, and we are looking at CR, which is these are the two things that we're looking at, which means DP into CR is equal to DA into PR. But I noticed that instead of DA they wanted DC, but let's just write that as well. Therefore DP into CR is equal to DC into PR, since DA equal to DC from 1. So that's what they wanted us to prove, and we've been able to do it. Very interesting question. The trick being to identify first which triangle, and then after you've identified, you realize that this is a adjacent triangle, so proving them similar may be very difficult. Let's look at a vertically opposite triangle. Good, let's look at the next question. The next question that we do is question number 17. Question 17 says FB is equal to FD, which means FB and FD are equal, which means triangle FBD is isosceles, which means angle B and angle D are equal. Done. AE is perpendicular to FD and FC is perpendicular to AD. We need to prove FB upon AD is equal to AD upon ED. So let's apply our trick and see if we can get FBC, which is this triangle, and ADE. Okay, let's see if we can prove them similar. Let me just draw these two triangles separately. This is AED and this is FB and C. So one angle is 90 degree. Any other angle that we can look at which will be equal. Yes, I notice that angle B here and angle D here are equal because these are angles of because triangle FBD is isosceles. So let's just write this down. I think we've already proven our similarity. So let's just write this. This is one angle. No, since FB is equal to FD, therefore triangle FBD is isosceles. What this gives me is point number 2. Therefore, angle FBD is equal to angle FDB. This is base angles of an isosceles triangle. Done. Now let's try and prove the two triangles similar, which is in triangle FBC and triangle AED. What we have is angle AED. Let's write, we wrote FBC first, so let's write the angle from FBC. So it will be angle FCB is equal to angle AED. FCB is equal to AED. Let's just check. FCB is equal to AED, right? This is equal to 90 degree. This is given. And the next one, angle FBC is equal to angle ADE. This is from 2. Therefore, triangle FBC is similar to triangle F. Corresponding to F is nothing, we don't know, is equal. B is equal to D, so number 2 would be D, and E is and C, which is 90 degrees, equal to E, so this is E. That leaves only A. So FBC is similar to ADE, which gives me FB upon AD is equal to FC upon AE is equal to BC upon DE. This is CSST. They want FB upon AD and they want BC upon ED. Let's just write that in the final one. Therefore, FB upon AD is equal to BC upon ED. Hence, proved. Perfect. That finishes this video for me. Let me just tell you your homework questions. Homework questions for you today would be question number 15. That's about it. Thank you so much. Take care. Be safe. I'll see you with the next video. Bye bye.